Alright guys, welcome to the Unit 5 Test Study Guide video help. I'm going to do the even problems for you guys, and you guys can do the odd ones, and you can check your answers with the answer key. Just make sure you do show your work to receive credit for those, okay? Alright, so let's go ahead and begin here. Every time I do an even problem, that should give you some information about how to do the one that comes right before it, which is the odd one. I tried to make them match in that way. So what we're being asked to do here is we're being asked to find the third root of this number. Now, anytime you're being asked to find a root, what you want to do is break your number that they give you down into its prime factors. Now, I know that 5 will go in there because it ends in a 5, so let's put a 5 here. If you need to get out a calculator, you can. But how many times is 5 going to 375? Well, let's see. It's going to go in there 75 times. And then we're going to break this down again. I know that 75 is 25 times 3, because I know how quarters work, right? Quarters do that. And then 25 is 5 times 5. So I've got 3 5s here and a 3. All right. We also have a b squared. And so if I were to break this down into its primes, we're going to have 3 5s, a 3, as well as 2 v's all being multiplied together. Now, when you're looking for a third root, what we're looking for is a number that's being multiplied by itself 3 times, which is what we happen to have here. So for every number that's being multiplied by itself 3 times, we can circle that group, which means I can write that number outside of the radical, and then cross off the group on the inside. Okay? Now, there's nothing else in here, though, that can come out. I don't have enough things in here that are being multiplied by themselves 3 times. So if nothing else comes out, you just multiply what's left in there together. And that pretty much will give you your answer. Now, for your test, just so you know, if you ever have a negative number in here, so long as it's an odd root, all you have to do different is just take the negative out and put it in the front. Okay? So you would end up with a negative answer instead. Now, also, we talked about how if this is a square root, it gives you an imaginary number, but I don't think we're going to really be getting in. On this test, I'm not going to test you on imaginary numbers, so you don't have to really worry about it. Okay? Let's go ahead and move on to number 4. So here's another one. This one is an even root. So we're going to do it the same way, but this time we're looking for groups of 4 identical numbers. So let's break down our 112. I know that 2 will go in there because it's an even number. I know that 56 is 8 times 7, and I also know that 8 is 2 times 2 times 2. So basically, if I were to break this thing down all the way, I would have 4 2's, I would have a 7, and I would have 3 n's. And now for me to apply this root, we're looking for a number that's being multiplied by itself 4 times. And for every number like that, we can take it out of the root. So in this case, I have a group of 4 2's being multiplied by itself. And so I can write a 2 on the outside of the radical this time. And then I have a 7 and 3 n's left on the inside. None of those come out. So we're just going to leave it like that now. So if you ever come across a situation, by the way, where you could take everything out and there is no more root, like let's say I gave you guys this one, the 4th root of 16. Well, in that case, there's just 4 2's, and so you circle your group, cross it off, and take it out. If there's nothing left under the root, then you don't put a root anymore. You just get rid of the root. Okay. But another thing is, we talked in class about how the 4th root of a positive number, anytime you have an even number here and a positive here, you technically get 2 answers, a positive and a negative. However, I just want you guys to know that on this test, the software I use, they don't include the negative answer. So whenever you're doing your multiple choice test tomorrow, don't be surprised if you only see the positive one. Now, if you see one that has an odd root with a negative number, the answer will have a negative included. But the ones with evens, my software only includes the positive output. All right. So that takes care of number 4. Let's go ahead and move on to number 6. So here's number 6. All right. Well, what we're dealing with here is we're dealing with what's called a rational exponent. In other words, an exponent that's a fraction. Well, all we have to do here is rewrite it as a radical problem because that's all that it is. The 8m cubed is what goes on the inside. The denominator of your fraction exponent is what goes as your root. And then the numerator of your fraction exponent is what goes out here. Okay? So now we need to find the third root of 8. Now, if you were to break down 8m cubed, what you're going to end up with is 2 times 2 times 2 times m times m times m. And since we're looking for groups of 3 identical numbers, I can take out a 2, and I can take out an m. And since there's nothing left on the inside of the root is now gone completely. All right. Now, if you have 2m being raised to the 4th power, you're going to apply that power to both terms, okay? And so I actually end up with 16m to the 4th as my final answer. Let's go ahead and take a look at number 8. Really, it's just another problem, so nothing too impressive there, but I'll go ahead and do another one. So this time we're finding the 5th root of 32m to the 10th, all being raised to the 7th power. And if you break down your 32, you're going to get 5 2's. And if you break down your m to the 10th, you're going to have 10 m's. And we're looking for groups of 5, which I have one for the 2's, so I can write a 2. I have another group of 5 m's right here, so I can take an m out. And I've got another group of 5 m's, so I can take another m out. And once again, there's nothing left on the inside, so we don't need the radical anymore. I can go ahead and put those 2 m's together, though, as m squared, so let's do that. And now we're going to apply the power. Now, so it's going to be 2 to the 7th power. And then for this, we're going to multiply those powers together. So it's actually going to end up being 14 for the m. So we got to figure out what is 2 to the 7th power. Well, just do 2 multiplied by itself 7 times, and you'll get your answer. Let me do a little mental math here. I know that 2 to the 5th is 32, so 1 more 64. So it's going to be 128 m to the 14th power. Okay? Let's go ahead and move along here. Check out number 10. All right, so now we're moving into solving equations. So when you're trying to solve a radical equation, the first thing you want to do is get rid of the numbers outside of the radical. So in this case, that means I want to get rid of this -5 and I want to get rid of this -1 hanging out in the front there. So the first thing we're going to do is we're going to add the 5, because you always do adding and subtracting first. So let's do that. That's going to give me -7 is equal to negative cube root of 4x minus 1. All right? The next thing we're going to do is we're going to get rid of this -1. And the way you do that is by just dividing both sides by -1, because that -1 is multiplying the root. So the opposite is division. So we canceled that out. Now I'm left with 7 equals the cube root of 4x minus 1. Once you get rid of the numbers that are on the outside of the root, we want to get rid of the root itself. And the way that you do that is by raising both sides to the power that matches this root. So I want to raise this to the 3rd power, because a 3rd power cancels out a 3rd root. And so I'll just be left with 4x minus 1 over here. Now on the other side, though, since I raised the right side of this equation to 3, I need to raise the left side of this equation to a 3rd power. And if I raise that to a 3rd power, gosh, I'm going to need a calculator for that one. I don't know what 7 to a 3rd power is. Just a second. I know 7 times 7 is 49, so if I multiply that by 1 more 7, I'm going to get 343. All right, the next thing we're going to do is just solve for x as a standard 2-step equation. Add 1 on both sides. That gives me 344 equals 4x. And then divide both sides by 4. I'm pretty sure 4 is going to go in there nicely. It's going to go in there 86 times. And so there's my answer. Okay. Now you would do the same thing if instead of a cube root, it was a square root. So if you had this, let's say we had this. Remember, we had this, right? A little second ago, we had something that looked like this. But let's just say that they didn't have a number here. Well, when there's no number there, that means it's a square root. So if you want, you can just put a 2 there. And so what you would do is you would square both sides, and you'd be good to go. Okay? However, I want to caution you guys against something. If you ever have a situation like this, it's okay. Because a cube root can give a negative answer, as we've seen earlier. But let's just say that you had this instead. Well, you might be tempted to go, okay, well, let's just square it. But the problem is if you do that, you're going to get an answer, but your answer is going to be wrong. And the reason for that is because square roots are not allowed to equal negative numbers. So if you ever see a square root, in fact, if you ever see any root with an even number for a root here, it can't equal a negative. So if you had that, that would be a no solution answer. So you got to watch out for those kinds of situations. All right, let's go ahead and continue on here to take a look at number 12. We're going to solve another one. This one's just a little bit different because unlike the last problem where we had just one square root, this one has a square root on both sides. So the way that these ones work is basically you're just going to start right off the bat by squaring both sides. Because both of these are square roots, so the way that we get rid of the square root is by squaring both sides. And that's going to give me negative 15 minus 2n is equal to 3n plus 30. And then from there you have a linear equation, which we talked about earlier this week, how to solve those. You move the smaller variable to the other side. And then you just solve your two-step equation. Now here's the deal though with these problems. So after we divide both sides by 5, we end up with a negative 9. Now, for these types of problems where you have a square root on both sides, it's important that you check your answers. Because it's possible that the answer you get is what we call an extraneous solution. You can also think of that as being a false answer. You did everything right, you get an answer, but it actually turns out it's not allowed. Now, I don't know if this one's extraneous or not, but the way you could tell, the way you could check your work is basically just by plugging it in. And what you should observe is that after you plug it in, you should end up with a true statement, but you shouldn't end up with any imaginary numbers. So, for instance, negative 2 times negative 9 is going to be positive 18. And positive 18 and negative 15 makes 3. So we have the square root of 3 there. On this side over here, if we plug in our negative 9 also, we have negative 27 plus 30. If we combine those, we also get a positive 3. So neither one of these are imaginary, and we end up with a true statement. Radical 3 does equal radical 3. So long as you have a true statement and no imaginary solutions, then it's a good answer. And so this is actually a good answer. But if you ever end up getting like a negative in here after you simplify it, well then we say, oh, that's not a good answer in that case. But in this case, we don't have negatives, so it is a good answer. All right? So like I said, once again, when you have square root equals square root problem, you got to check your answer. Because it's possible you end up with an extraneous solution, which means a false answer. All right, let's go ahead and take a look at number 14. Now, for number 14, this is a situation where we have a square root being equal to a variable. When that happens, the solution process is a little bit different. So when you have a square root equal to a variable, basically there's two things. First of all, once again, you have to check your answer. And second of all, the way that you actually even get your answer is you're going to end up having to do the quadratic formula. Because you're going to end up with a quadratic expression, probably. All right, so let's go ahead and begin. Once again, just like on the other ones, we start by squaring both sides. And on the left side, the square cancels out the square root, so we have this. And sure enough, we end up with a quadratic equation there. A quadratic equation is an equation where you have a variable to the second power. And so we want to get this in standard form where it's equal to 0 so that we can use the quadratic formula. So the first thing we're going to do is we're going to add k on both sides, and we're also going to subtract the 42 on both sides. That way we have 0 equals k squared plus k minus 42, which is a quadratic equation in standard form. All right? Now, we're going to take the coefficients. The first coefficient is a, the next coefficient is b, and the last one without a variable is the c. And we're just going to do the quadratic formula to solve for k. Now, I'm pretty sure most of the time the problems that they're going to be giving us here are going to be ones that work out nicely. In other words, you shouldn't end up with weird square roots in your answers or anything. You should end up with some pretty nice answers in the end. That's just how the software I use works, and quite frankly, I prefer those kinds of answers, especially for these types of problems. So we're going to plug the b in here. Forgot to write the rest of it. And we also plug the b in here. The a goes in here and here, and the c goes here. All right, so let's go ahead and start simplifying this a little bit. Now on the inside here I've got 1, and then this is going to be a negative 4 multiplied by a negative 42. So when you put those two things together, it's going to come out positive. So 42 times 4 is 168. So this makes a positive 168. So if you add that to the 1, you actually end up with 169 there. And on the bottom we have 2. And as promised, the square root of 169 is actually a nice square root. If you need to break it down by hand or use a calculator, go ahead. But ultimately, you should end up with 13 as the square root of 169. And after that, you're just going to split it up into two separate problems. One where you have plus 13 over 2, and another one where you have minus 13 over 2. And so for the one over here on the left, negative 1 plus 13 is 12, divided by 2 is 6. The one on the right, negative 1 minus 13 is negative 14, divided by 2 is negative 7. And so my two answers that I'm getting are 6 and 7, which are nice answers, as I said. But once again, even after you do the quadratic formula, you need to check your answer to make sure that it actually works. And the same thing applies this time as last time. It has to be, you can't have an imaginary answer, and the left side has to equal the right side. So let's see if both of these answers are any good. So, first of all, let's check the 6. So I'm going to plug in 6. Right? Because 6 was one of my answers, right? So, if I plug in 6, 42 take away 6. What is that? 36 maybe? Oh, I forgot to plug it in over here also. My bad. Sorry. So 42 take away 6 is 36. And the square root of 36 is, lo and behold, 6. We got a good outcome there. Let's go ahead and check out 7 now, because we got to check out both. Since we got two answers, we have to make sure that both of them work. So let's go ahead and plug in the 7 and see if that one works. So double negatives become a positive. So I have the square root of 49 is equal to negative 7. And the square root of 49 is 7, and those things are not equal to each other. And therefore, we're going to say that's actually a no solution type of question there. And we're going to go ahead and drop that out. Okay? So that is not a viable solution. All right. Let's go ahead and move along into number 16. Now we're going to talk about graphing. And they also want us to state the domain. So stating the domain, let's start with that because that's a little bit easier. All you do basically is you take what's underneath the square root and you make it greater than 0. So that's what you're going to do for square roots. Now cube roots, you'll do something a little bit different, but for square roots, this is what you do. And actually, it should be equal as well. So we're going to go ahead and solve this. And now, whenever you divide by a negative, you need to remember to reverse your inequality. So my domain is x has to be less than or equal to a negative 2. All right? So that's that first part. Now, they also want us to graph it. Now, we saw this a little while ago when we were doing transformations, but when you have a number in front of the x and a number being subtracted from the x, you need to factor that out. So let's go ahead and do that first. I'm going to pull out that 2 there, which is going to leave me with this. So anytime you have a number here and here, you need to divide it out of both of those terms. So if you divide this by negative 2, you're left with x, and if you divide this by negative 2, you're left with a positive 2. Okay? Once you've done that, you're ready to graph it. Now for square roots, you're going to take this number and the opposite of that number, actually, which is negative 2, and this number as your y. And those two things put together are going to make up your starting point. Okay, so my starting point will be negative 2, positive 1, which is right about there. All right, the next thing we're going to do is we're going to look at this number here in the front and this number here in the front. Actually, let me put 1 there. And this number here. Now, if the number in the front is negative, that means you go down. If it's positive, you go up. And if this number here on the inside is negative, that means you're going to go left. If it's positive, that means you're going to go right. So my graph is going to go down and left from this starting point. And it's going to look something like that. So you have to know what the general shape of a square root function is in order to get that correct. But there it is. So you got to make sure that you get your starting point right. So couple things. Anytime you have this here with a number here, you got to factor it out. Then you find your starting point, and then you use these two numbers to determine the direction of the graph. Let's go ahead and move on to number 16. Well, we already did 16. Let's do 18. All right. So number 2 is a cube root function, and it's very, very similar to square roots. First of all, though, if you want to know the domain, anytime this is an odd number, the domain is just all real numbers. That means x could be anything. It's not like a square root where this part underneath the square root has to be greater than or equal to 0. For cube roots, the domain could be anything. X can be any number you want. Okay? So there's that part. But let's go ahead and do the graph. Now, first of all, we're missing some numbers here. I don't have a number in the front, so I'm going to put a 1 there. And I don't have a number over here, so I'm going to put a 0 here. Also, I'm not really very fond of the order of these things. We like to have the x first, don't we? But you're noticing that that x is negative. And that means we actually do have a number here in front of the x. So like I said, anytime your x is being multiplied by something and you have a number here, you need to factor it out. So once again, I'm going to factor out that negative 1 from the front, which is going to change it to look like this. All right, from there, we're ready to begin. My starting point is going to be positive 4, 0. And my direction is going to be up and left because of the positive 1 in the front and the negative 1 in the front on the inside. So, starting from my starting point, 4, 0, which is right here, I'm going to go up and left. So that's going to look like this. Now that's for square root functions, but this is a cube root. But the good news is cube roots do the same exact thing. So after you graph that, you just have to do one extra little thing, and you just have to add a reflection of that going in the opposite direction. And there is the graph of that cube root function. So once again, in this case they're in the wrong order, so I reversed them. And after I reversed them, I saw that I need to factor out the negative 1. And also, once again, just like we do anytime we're graphing, if you're missing numbers, you need to fill them in. Okay, so there you guys have it. That's number 18. And I think that might be it. Let me see. I don't remember. No, we have some more. Let's go ahead and take a look at number 20. All right. So these are equations that have rational exponents. So how do you solve these? Well, the first thing you do is you get rid of any number that's not under the influence of the power. So for instance, the only thing that's being affected by this power of 3/2 is the x. But the 3 here is not being affected by the power. So I'm just going to divide both sides by 3 to get rid of that number first. So anything that's not under the influence of the power, get rid of it first. So if I divide both sides by 3, let's see, it's going to go in there 6 times and then 4, so 64. All right. Once you've gotten the expression that's under the power, under the influence of the power by itself, the next thing you're going to do is you're going to raise both sides of this expression to the reciprocal power. So instead of raising both sides to the 3/2, we're going to do the reciprocal of that. We're going to raise it to the 2/3. Why? Because when you multiply a fraction by its reciprocal, they cancel each other out and just leave 1. So now we're just left with x to the first power. So I got rid of the power there. And now I have this. And now we've got a flashback to some of our earlier problems that we were looking at on some of the earlier problems. So to solve this, we need to transform it into radical form. Next, you're going to break down the number that they give you. And 64 turns out to be 6 2's multiplied together, like that. And we're looking for groups of 3, so there's one group of 3. There's another group of 3. Two times 2 is 4. And then 4 squared is 16. And there's my final answer. Okay? All right. So let's go ahead and move on to another problem. Let's do number 22. Now in this case, the entire expression on the left side is under the influence of this power. So our first step is usually to get rid of the numbers that are not under the influence of the power, but in this case everything is. So I can't get rid of any numbers yet. So the first thing I need to do is I need to raise both sides to the reciprocal power. Now the reciprocal of 1/3 is positive 3. Now if you want to write it as 3/1, you can, but on this side I wouldn't do that. I would just leave it as 3, otherwise it'll be a little confusing. Now 3 times 1/3, those two things cancel each other out, and you're going to be left with 6n plus 29 equals 5 to the 3rd power. Now luckily this one's a little bit easier than the last one. We had 5 to the 3rd power. That's just 5 times 5 times 5, which is 125. And then from here we just have a nice little two-step equation to solve. I want to say that's going to be 96. And I end up with 16 as an answer. Okay. Let's go ahead and take a look at number 24. Pretty sure that's the last one that I have to go over here. I know there's another one, but I think that one's extra credit, and I'll leave that to you guys. But for number 24, 23, let me go forward one more. There we go. For 24, this is an example where you're going to end up with 2 answers, and you'll see why. Okay, so first of all, the first step is, of course, to get rid of any numbers that are not under the influence of the power. But once again, in this case, everything is under the influence of the power there. So we can't get rid of any numbers yet. But what we can do is we can get rid of the power. So let's get rid of that power by raising both sides to the reciprocal power. Okay, so those cancel. And now I'm left with 2x equals 64 to the 5/6 power. Now, for this particular problem, we're going to have to do the radical thing again. So we're going to change this into a 6th root of 64 raised to the power of 5. Now, 64 breaks down into 6 2's. And that happens to be exactly what we're looking for. We're looking for groups of 6. So I can circle that entire group of 6, cross it off, and put a 2 here. And since there's nothing else left in the radical's gone. But before you get too cozy, this is a problem where you're going to end up with 2 answers. Okay, and the reason for that is because, once again, we have an even root with a positive number, and my software this time will include the signs. So you're actually going to end up with a positive 2 and a negative 2. Anytime you have an even root with a positive radicand, for these types of problems in particular, you're going to get a plus and a minus. So now we're going to raise it to the 5th power. And when you raise a positive 2 to the 5th power, you get 32. And when you raise a negative 2 to the 5th power, you get a negative 32. So now, since I really have 2 numbers over there on the right, a positive 32 and a negative 32, at this point we really kind of need to write 2 separate equations. And we're going to solve both. So and there you have it. X equals 16 and negative 16. Okay? And I think that does it. Like I said, for number 26, 25, and 26, those are extra credit questions, which as I make this video for you guys, I still haven't made the extra credit video yet, so I'm not sure if I had time this week. By the time you're watching this, I'm not too sure if I had enough time to make the extra credit lesson. So I'm not sure if you guys got to this or not. But either way, do it if you want, and you can get extra credit on the test. But if you don't want to, that's okay. All right. But I'm going to leave it there at that, and I'll bid you guys good day, and we'll see you for the test.